Hello everyone and welcome to Quadratic. So this video will discuss this year's trial paper, which is from Kedah, and will focus on paper 1. Alright, so let's get right into it. And for the next question, it comes from the chapter Differentiation. So in this question, we have a hemispherical bowl. So hemispherical means a sphere that I cut into half. Alright, so this is hemispherical, as you can see in diagram 10a. And diagram 10b shows the cross section of this bowl. So it means if I cut this bowl by half and I look from this direction, you will view something like this. Okay, and here is the water. Right, so now they also gave us some additional information. So the radius of the bowl here is 10 cm, and the height of the water is h. So now we need to find the surface area of the water. So this means that if I view it from the top, the surface area will look something like this, a circle, because the bowl is a hemispherical. Okay, so to find this surface area, we need to use the formula, which is pi r squared. Alright, so now the problem is, how do we find the radius, which is here? And how do we prove that the surface area of the water is this equation? Okay, so what we can do is we further utilize this radius. Okay, so the r is here, and I can draw this radius in 3 ways. Okay, which is this 3. Okay, so this is the one that the question gave us. So this is the another line that we can draw. So it connects from the center to the circumference, and this as well. Center, circumference. So the reason why I draw these 3 lines is because here it actually forms a right angle triangle, if you see closely. So actually we can use the Pythagoras theorem to help us form an equation and find the value of r. Okay, so now what we need to do is to find the length of this line. So here is h, so this means here is 10 minus h. Okay, so I clear a bit for a while. Okay, so now I will use the Pythagoras theorem. So here will be r squared plus 10 minus h squared equals to 10h. And now I move everything which is not r to the right side. Okay, so I further simplify and I will get r squared equals to 20h minus h squared. Reason I don't move the square to the right side is because, as you can see here, we need r squared. Okay, same as here. So to find the surface area, we just sub this 20h minus h squared directly to here, and we have proved the equation. For the next part, part B, we have so let's say we've added some water inside this bowl. Okay, so there will be some inaccuracies when we are trying to measure the water height. Okay, so it says there will be an error of 2% for the small changes in water height. So now we need to find the small changes of the surface area of the water, okay, which we label it as A just now in part A. Okay, so to find small changes, we can use this formula. Delta y over delta x approximately equal to dy over dx. So in our context for this question, we need to find delta A, because here it says find the small change in the surface area, delta A. And why here we put delta h is because this A and h are further related to each other. As you can see in part A, we already have formed this equation. A and h are related. Okay, so now since here is A and h, the right side will also have A and h as well. So in order to find small changes, we only need to have 2 things. One is this, and the other one will be this value. Okay, so this I will need to move it to the right side. So there will be always have 2 things we need to find for small changes. One is the differentiated equation, 2 is the delta h. Okay, so to find dA over dh, this will be quite easy because we can use the equation from part A and we differentiate. Okay, so here 20h, I just pull down the number, and for this one I just put the power to the front and I minus 1 for the power, so it will become 2h. Okay, so this is the first thing. And the second one, delta H. So here we can actually find this using this sentence. The error of 2% for small changes in water height. Okay, so this is a percentage change, and percentage change we actually have a formula for it. Okay, so percentage change equals to delta x over x. Okay, so delta x here means the small change, and x here means the original x. Okay, so for our context, this is water height, so you change all the x to h. And they already gave us this percentage change, which is 2%. So I will sub the 2% here on the left side of this equation. Delta x, I will change it to delta h, x to h, and the 100% will remain. So here I will just rearrange this equation to let delta x on the left side, and we will get h over 50. So now we have these two things, and now we can further multiply them together. Okay, so it'll be something like this, and at the end we will get this equation. Next question comes from the chapter Trigonometric Functions, and for part A we are given this equation, and where A is an obtuse angle. So obtuse is actually the angle between 90 to 180, or meaning it is at the second quadrant, which is here. Okay, so now we need to express another trigonometric function, cotangent A, in terms of P, which is from here. Okay, so for this kind of question, let us draw out the triangle first. Okay, so since the second quadrant, 90 to 180 is here, so I will draw this triangle here, and the angle A, I'll draw it here. Okay, so now sine A means opposite divided by hypotenuse. So here equals P. This means that it can be P over 1. So opposite would be P, hypotenuse would be 1. Okay, and since we have these two sides, we can find this side using the Pythagoras theorem. So the Pythagoras theorem would be square root hypotenuse 1 square minus P square. Right, so 1 square is actually 1 also. But another thing here we need to take note is sometimes the value will be negative. Okay, so you can imagine that you are finding the coordinate here. So as we know, this coordinate for the x coordinate is actually negative, correct? Because it's on the left side of the y-axis. Okay, so here we need to take note that we need to add this negative. So sometimes students will confuse or miss out this negative and positive, causing the answer to be incorrect. Okay, so make sure you take note that whether should we add positive or negative. Okay, so now cotangent A means 1 over tan A, and we know that tan A is opposite divided by adjacent, but this one is the inverse of tan A, so we can inverse this as well, which means A over O. So A here is the adjacent, so it's minus square root 1 minus P square divided by the opposite, which is P. Okay, so this will be our answer. And for part B, we need to find we need to solve this equation, and we only accept the x value between 180 to 360. Okay, so this one is actually very familiar because there is only one formula in this chapter that sticks cos x and sin x together, which is the 32nd formula in our formula sheet given in SPM. Okay, as you can see here, sin A, cos A. Right, so what we can do is, because there is 2 missing here, so you can just move the 2 to the left side to get this, and then we can directly change this to become sine 2, this is x, so means it's sine 2x. Okay, so here is actually a special case because the value is 1. Okay, so special case values would be -1, 0, and 1. Reason I would say this is because you cannot use the calculator to help you find the answer. We need to draw the graph out, right? So sine would be something like this. Okay, and 1 only appears here, which is the 90 degree. See, okay, so this would be one of the answers. And since this is 2x, okay, so 2x means, x means I go one round. 2x means I go another round. So let's say if my line is somewhere here, you can see that it intersects 2 times. So we need to have 2 answers for this case. Okay, so how do we find the other answer? So the first value is 90. So since we go another round, which means we are adding 360. So here I would add 360 to 90 to get the second answer, 450. Okay, and then we need to find x, not 2x, so I'll need to divide these two values with 2. So it will be 45 and 225. So remember, the condition is x must be between 180 and 360. So since it is given this condition, x can be only 225. Alright, so for question 12, it comes from the chapter Permutations and Combinations, and for this case we have 6 types of faces, and for part A we need to arrange these faces into a 2-tier display, right? And there is a condition whereby the number of faces of the top tier must be less than the bottom tier. Okay, so let's list out the possibilities that this will happen. Okay, so top tier must be less than bottom tier. So it couldn't be 3 and 3. So let's start from 2. Right? So if top tier has 2, so this means 4 faces will be at the bottom tier. Or we minus another face from top tier. Let's say now it's 1. So bottom tier would be 5. But I cannot consider a possibility that here is 0, because there's a condition whereby we need to arrange all these faces to a 2-tier, which means top and bottom must have a base. Okay, so we cannot consider this possibility. Alright, so now let's find out the number of arrangements for each possibility. From these 6 faces, we need to choose 2 out and we need to arrange them. Okay, so this would be 6P2, not C. Okay, so let's say if I choose plum and beaker, I can arrange them, like for example, plum then beaker first, or beaker then plum. Alright? And then, since we already chose 2 out, there is only 4 left. And we need to arrange them according to the number of spaces that we have, which is 4. So here will be 4P4. Here is not 6P4. Reason is because we have already taken out plum and beaker. Okay, so this is not possible. Same goes to the second possibility. Here from 6 faces, we choose 1 out to arrange. So let's say there's only plum for this case. So here we have 5 faces left, and we need to fill in these 5 spaces. So it's 5P5. So let's calculate the number of arrangements for this case. Alright, so we'll get 1440 as your answer. And for part B, so this archaeologist has found another Volkswagen vase and 2 Begonia cakes. So let me change the values. So here will be 2 and here will be 3. Okay, and now we need to find the number of ways to arrange all the faces at the bottom tier only. Okay, so now there's only 1 tier with the condition that this Volkswagen vase, which is these 2 Volkswagen vases, must be placed next to each other. Okay, so for this case, let me represent each of the vase with a letter. Okay, and I will write the letters according to the number of vases that we have here. Okay, so C, there will be 2, E, there will be 3. Okay, and this Volkswagen vase, which is C, must be placed next to each other. So let's group them as one big vase. So here there is only 1 object, not 2. 1 object. Let's say there's a big mega C here. Okay, so we will always, if you see next to each other, make sure you need to group them as 1 object. Alright, so now let's assume that we are arranging these letters. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there will be 8 factorial, but here we have identical letters. So as we know, identical letters, we need to divide our current number of arrangement divided by these factorials. Okay, so number of factorials actually depends on how many type of objects that have identical. So here we have only one type that has identical, which is E. Okay, there's 3 of them. So we only need to we only need to divide one factorial, and the number here depends on the duplicates that we have. So here we have 3 E's, so we would divide 3 factorial. Okay, so we divide 3 factorial. And for the C here, so sometimes for next to each other objects, we need to switch their places, correct? And we multiply 2 factorial. But for this case, since both of them are the same base, if we switch their places, there's no changes, correct? So here we don't need to multiply the 2 factorial. We don't need to, because these two are identical. Okay, so here we just need to 8 factorial divide by 3 factorial to get the answer, which is 6720. Alright, so for part C, this enthusiast bought for each type, this person bought one of it. Okay, so now goes back to the same arrangement. So here would be 1, here would be 1. And this person wants to arrange these faces in a circular manner, but in the condition where plum and the Volkswagen face cannot be placed with each other. Okay, so for this kind of cases, actually next to each other, to find the number of arrangements next to each other is easier than to find not placed. Okay, so to find the possibilities, what we can do is, let's consider all possibilities first, and we minus out those possibilities that they are next to each other. So if I minus, this means I will get not placed to each other arrangements. Okay, so again, to find all arrangements, let's represent each of the face with a letter. Okay, so as we know, for a circular arrangement for all, we need to use this formula, n minus 1 factorial. So n here means the number of faces that we have, so here we have 6. Okay, so it's 6 minus 1, and we will get 120. Okay, so this is done. And now we need to find the arrangements that are, that the plum and the Volkswagen face are together. Or if in the letter form, it will be A and C must be together. Okay, so let's group them together first as one big vase. So now there are only 5 objects that we need to arrange. 1, 2, 3, 4, 5. Right? So n we will sub 5 minus 1 factorial. And here there's a 2 because again, these are grouped together. So there is a possibility that I can switch their places. Right? CA or AC. So I need to multiply A2 factorial to get 48. So now we have these two things, and we can find the number of arrangements which they are not together. So I'll just minus 120 with 48 to get our answer, which is 72. Alright, so question 13 is actually the first question for section B, and we know that section B, for each of the questions there will be 8 marks, right? So this question comes from this chapter, probability distributions. And for part A, we need to find the standard deviation for this normal distribution. Okay, so to find the standard deviation, we need to have a statement first, or an equation first. So we can use the information from the grade A Musang. Okay, so as you can see here, grade A, we consider grade A if the mass is more than 1.7 kg. And it also says that this grade A percentage is actually 63%. So if I want to draw this out, I would say that starting from 1.7, if I sketch to the right side, all these values are actually more than 1.7, which means this area is actually 63%, because all are from grade A Musang King. Alright, so I would use this information to form an equation. Okay, so I'll let X as the mass of Musang King first. Okay, then I'll make this statement. So this means probability that the mass of Musang King is more than or equal to 1.7, which I taken from here, is actually 0.63, which I have taken from here. Okay, so now when we have this statement, we can slowly figure out the standard deviation. Okay, so the first thing is we need to standardize from X to become Z using this formula, right? So we need to X minus mu divided by our standard deviation. Okay, mu is mean, and this mean actually is from here, the 1.88. Okay, so make sure that you know that this is actually mu. Right, so if I put it here and I simplify it, so above will be negative 0.18. Right, so now we need to use the table, which is this table, normal distribution table, to help us find the value, this value. Okay, so the ideal graph that we can find our information from the table just now is this graph. Okay, so there will be two checks. One is the area must be sketched from the right side. Second one is the area must only be on one side. So if you look at this graph, you can see that yes, it actually sketches from the right side, but one side it fails because it involves both sides, left and right as well. Okay, so this graph fails. So now let's focus the other way. Instead of focusing on the red part, let's focus on the white part, because this area only involves one side. But the problem is it is not from the right side. It's okay. Okay, so let's write this thing into another way. Okay, let's say if I want to find this area, what I can do is I would consider the whole area. So this means the probability is equal to 1, correct? And if I want to find this area, I need to minus out this white color part, correct? So it would be somewhere here, and this value is actually negative 0.18, which I gotten from here. So if I minus these two values together, we will get this area, or equal to 0.63. Right, so now let's bring our focus to this graph, because this graph can help us to find the value here. But the problem is, this graph's area is on the left side. What we need is from the right side. Okay, so this is actually quite easy and quite lucky, because this is a normal distribution curve. This is a bell-shaped curve, which means it is symmetric. Both sides have the same shape, which means this area I can move it to the right side. But the only condition is this value needs to become positive. So let's say if this value is positive, I need to make it to become negative. So we need to change the sign when we move. Okay, so now I can use this statement to write out the equation. So here is 1. This one is minus p z more than or equal. More than or equal is because now I am sketching to the right side. And just now there is this more than equal to here. So I need to write this equal to sign here. And this negative value become positive. So I would change it to become 0.18 over sigma, the standard deviation, and would be equal to 0.63. So now I can move this one to the right side, and I'll get 0.37. So now I am ready to use the table to help me find the value here. Alright, so let's go to the tables. Alright, so the value here is 0.370, and I need to find the value which is larger than this value but the closest to 0.37. Okay, so if you glance through, this would be the most closest value to 0.37 and it is the largest, larger and closest to 0.370. Okay, sorry, I need to use another color. Wait for a while, yeah. Okay, this one. So there is a big difference between these two values. Okay, so I need to minus them first. Okay, so if I minus them, it will be 7. Okay, the other values I don't need to care. I just need to care the value at the back. And this value I need to search from this part. The other columns. Okay, so from this row, you can see that the 7 is here. So we have actually found our answer. So here we need to have 3 values. So the first value will be from this column. So it's 0.3. Then I need to find the next value from this column, which is here, 3. And since 7 is here, I need to just look up, and this would be my third value. So if I combine these 3 values together, our answer is 0.332. Okay, so this is our answer. So going back to the working that we have, according to the tables, if z is more than or equal to 0.332, this would be 0.37. So now to find the sigma, I can just compare these two values. Okay, and to find the standard deviation or sigma, which is 0.542. For part B, we are given the percentage of Musang King grade B, which is this value, and we need to find the range of the mass if we want to consider the durian as grade B. So we need to find two values. What is the minimum and the maximum mass to consider that durian as a grade B durian? Okay, so if we look back to the table here, you can see that from this row it says grade B and C must be less than 1.7. So this is the maximum value, right? So this I'll change it to 1.7. So now we need to find the minimum value, but let me denote this as x now. Alright, so now for the value x and 1.7, I will draw it in this diagram first. Okay, so x will be somewhere here and 1.7 will be slightly to the right of x, okay, which is here. So this means for this area, the probability is this value. And what we saw in part A, for the durian which has more than 1.7, the probability or the area here is this value, 0.63. So this means that the probability that the durian would be more than x, which is this part, is actually the addition of these two areas, which is 0.8953. Okay, so now similarly to part A, if we want to find the value of x, we need to consider this part, this small part, because this is the ideal graph that we need to have, right? The area should be on one side only. So let us find the area for this white color part. So it's 0.1047. So let me write out a statement for this part. Okay, so here I'll write the probability that x will be less than x is 0.1047. Less than is because now the area is like going to the left. Alright, so left means we need to write out the less than inequality. Okay, so now we need to let x to become z. So now we are standardizing this thing. Okay, so the standardizing formula is this one, x minus mu divided by sigma, which we already found in part A. Okay, which you will get this value. Okay, so now the area is still on the left side, so let us change it to the right side. Okay, so by changing to the right side, make sure the things which are positive, you change it to negative and negative to positive, as you can see here. X becomes negative x negative 1.88 becomes positive 1.88. So now you can see that the inequalities also change as well, because just now was this part, which is less than. We are going to the left. So now we are going to the right. We need to change our sign to become more than. Right? So now we are ready to go to the tables to find the value of 0.1047. Alright, so now we need to find the value which is more than but closest to 0.1047, which is this value. Okay, and now let us find the difference between these two numbers. So by minusing, this would be 9. Okay, so according to these columns and according to this row, we need to find the value of 9, which is here. Right, so now we can find the three values that we want, which is 1.2, 5, and 5. Right, so let's go back. And according to the tables, we have found that it is 1.255. So now we can compare these two values and find the value of x, which is 1.199 kg, which is the minimum mass to consider the durian as a grade B durian. Right? So this is our final statement. The x is between 1.199 and 1.7. And for part C, hence means that we need to use the answers from A and B to help us find the number of grade C if the total number is 1200. So now we only need to find what is the probability of a grade C durian, which we already found because here you can see that more than X is actually the durians which are grade A and grade B. So if it's less than, which is this part, the white color part that we have, this area is actually 0.1047. So to find the number, we just multiply the total number and the probability. Okay, so our answer will be 125.64, and we round it up to the nearest whole number, it will be 126. Alright, next question comes from the chapter Integration, and for this diagram we have a cylindrical drinking water jug and the diameter is 18 cm. And also another information is this maximum volume of water to fill in this jug is 972 pi. Right? And now to find the value of D, we need to multiply 1 over 3 with the diameter of the water in the jug, which is the 18 cm. Okay, and to find the value of T, we need to multiply 1 over 3 as well, but with the maximum height of the water in the jug, which is H. Alright, so now let's go to part A. We need to find the value of T. So T actually depends on H, correct? Because we need to multiply 1 over 3 with H to get T. Okay, so now we need to find the height of this jug. So one of the information they've given us is the maximum volume of water is 972 pi. And this jug is actually a cylinder. So we can use the volume of cylinder to help us find the value of H. Okay, so volume of cylinder will be 972 pi, and the formula is pi r square H, correct? So we will sub r with 9 because the diameter is 18, so I need to divide by 2 to get the radius, which is 9. Okay, so if I move everything to the right side except for the H, it will be 12 cm. Okay, so we know that T multiply 1 over 3 with H, we will find T. So T equals to this, and we sub 12 to get 4 cm. Okay, so this is part A. Right, so part B, we need to find two things, which is the value of K and the equation of the curve for the water in the glass, which is this equation. Okay, we need to find this equation if the gradient function is kx. Okay, so gradient function here means dy over dx. Okay, reason is because sometimes dy over dx we can use it to find the gradient of a line. Right? So that's why gradient function is dy over dx. Okay, so now to find the equation of the curve, the original equation of the curve and the value of k, we need to integrate this equation, kx. Okay, so here I will denote this as f prime x or in other words, this is also dy over dx lah, another way of writing. Okay, so I need to integrate it. So I'll write in this way, kx and then dx at the back, and be a integral in the front. Right, so if I integrate, I need to add 1 to the power. So here it's already 1, so 1 plus 1 equals to 2, and I need to divide the new power. And here the integral does not have the range, the limits. Okay, so I need to add c at the back. Okay, so now we need to find three things: c, k, and the equation. So what we need now is some points in this diagram, because the diagram they show us the x and y axis here. Okay, so now we can use the information that we got from part A. So we know that t is 4, so if this is the origin, which means this is 0, 0, if we go 4 units downwards, this point would be 0, negative 4. Correct? Right, so we can use this point to help us find one of the unknowns. Okay, so if I sub 0 to x and negative 4 to f of x or y, we will get c equals to minus 4. Okay, so this is the first thing that we have calculated. Okay, and now we need to find the value of k. Right, so here we need additional points. Okay, but one of the things we haven't used is the d. Okay, so as we know, d is actually, if you want to calculate d, we need to multiply 1 over 3 with 18. Okay, so d would be 6 in this case. Okay, and since this d is actually the middle of the y-axis, so I can split it into 2, 3, 3, and using the same way as well. So since here is 0, if I go 3 units to the right, the coordinate here would be, the coordinate here would be 3, 0, right? 3 units to the right, and this one the same thing as well, but it's going to the left, so it's negative 3, 0. So we can use one of the points to help us find k. Alright, so here if I use 3, 0 and I sub 3 with x, f of x with 0, I will get k equals to 8 over 9. Right, so the second thing we already calculated. So now to find the equation, we just need to sub everything to the equation here lah. So this k, we need to sub 8 over 9, but make sure it will be divided by 2. So in the end, we'll get 4 over 9, and the value of c will be here, negative 4. As for part C, the question asks, if we have 3 identical cylindrical jugs, how many glasses can I fill the water with? Okay, so the first thing is, let's calculate the total volume of water first. Okay, so we can use the 972 pi and we multiply by 3, okay, to get the total volume of water, 2916 pi. And now we need to see how much of volume can a glass hold, right? So we need to find the volume of this glass, okay, which is this part. Right, so since this is within a curve, to find the volume we need to integrate. Right, so integrate, we have two ways. Either we rotate around the y-axis or the x-axis. Okay, so for this case it would be logical if we rotate around the y-axis, correct? Because if we rotate around the x-axis, our volume will look something like this. Okay, so this is the down part and we rotate upwards, so it will count the volume here as well, which we don't want, correct? So here we will just use dy, or rotate around the y-axis. Right, so let's use this. So pi, then we have an integral here. Okay, so the limits here, since we are using the y-axis, let's find the lowest y value. Okay, so it's this point lah, which is negative 4. And the highest point, or the highest y value, is 0. Okay, so we put it here, and we will just follow x squared and dy. Okay, so the x squared, we need to change it depending on the equation of the curve, which we have found in part B. Okay, so here I'll write it here lah. Okay, so from part B we found that the equation is this. So since now we want x squared, we need to let this equation, we need to rearrange this equation where x squared will be on the left side. Okay, so if we move everything to the right, x squared to the left, we will get this expression. And then we will sub it here. Right, so since 9 over 4 is a constant, I can move it out first. And we will integrate the things inside here. So here, y, if we integrate, we will add 1 to the power, so it will be y2 over the new power. And for the 4, we will just add the y. And don't forget the range, 0 and -4. So we will sub 0 and -4 into this, right? And this will be the result. So if we sub in 0, everything will become 0. And if we sub -4, y will become -4 in this case. Right, so if we simplify, we will get 18 pi cm cubed. Okay, so to find the number of glasses needed, we will just need to divide the volume of water that we have divided by the volume of the glass. So which is 162 glasses needed for this case. Last question comes from the chapter Quadratic Functions, and we have a diagram which we can see that there are two sticks supporting the hammock, and it says that the lowest point of the hammock is h meters above the water surface. So if we view this situation as an x and y axis plane, right? So if we let this stick as the y axis, this water surface as the x axis, the hammock as the curve, the y coordinate of the minimum point, because here it says the lowest point means minimum point, the y coordinate of this point is actually h, because it says that the minimum point or the lowest point of this hammock is h meters above the water surface. Okay, so if we let the water surface as the x-axis, which means here is 0, the y coordinate of the minimum point will be h. Okay, so it also gives us the height of the function of the height of the hammock, which is this. Okay, so the line's equation would be 2 over 3x squared minus 4 over 3x plus 1. And now we need to find the value of h. So this means that we need to find the minimum, the y coordinate of the minimum point. Right, so how do we find it using this equation? We can actually use the completing the square method. So that would be 3 steps. Okay, so the first step is to let the number of x squared to become 1. Okay, so means we need to factorize out. So here, if it's 2 over 3, we need to factorize 2 over 3 out, along with the values which have x. For example, this one. Okay, so this 4 over 3, I need to divide 2 over 3. Okay, divide 2 over 3. So here we will get 2x. So if you want to double check this, you can just multiply back the 2 over 3 to see it. This is the same as the one above here. Alright, so the second step is to add this thing. Okay, so where does this come from? Right, so this -2 depends on the value here. Okay, so if you need to look at the value of x. If the value of x is -2, you need to write it here. And then we need to divide 2 and square this value. Okay, so if we add this value, we also need a counter effect, correct? So we need to minus. So we need to minus the exact thing. And the plus 1, we can just put it out of the bracket first. Right, now going to the third step, we need to combine. Alright, so combine means for the values that have a square on top, which is this one and this one, we need to put their values inside this bracket. Okay, so the x, I'll put it down, and here is -2 divided by 2, so it will be -1. And for this negative 1 actually comes from here. This one is just to simplify it. Okay, so 2 divided by 2 will be 1. So negative 1 we need to square, it will be 1. So here will be negative 1. Okay, and then we just multiply the value 2 over 3 inside these two values, and we will simplify and we will get this value. Okay, so this is actually known as the vertex form, which means it helps us to find the minimum or the maximum point of this equation. Sorry, the curve. So here the minimum point would be 1 over 3. So this means h is 1 over 3. Alright, next question is for part B, a tourist lies down on the hammock. So this hammock drops a 0.5 meters, right? So if you want to write our new equation for this case, we need to minus 1 over 2 because it is lowered down by 0.5 meter or 1.2 meter. Okay, so we do minus. Alright, so now we want to, for part 1, we will check, show that using discriminant, the hammock will be under the water surface. Right, so the first thing, what is discriminant? So discriminant is this value, b squared minus 4ac. So how does discriminant relate to the question that we are solving? Right, so if we view this situation as the x and y axis plane, the hammock now is something like this. We want to check whether this curve intersects the x-axis by 2 points, as you can see from this diagram, 2 points. So we learned that if b squared minus 4ac is more than 0, this would be the case, intersects 2 points. If b squared minus 4ac equals to 0, means it intersects 1 point only. If b squared minus 4ac is less than 0, means it is above the x-axis. Okay, so now we need to prove that whether the b squared minus 4ac is more than 0, because this is the only graph which intersects and is below the x-axis, which means it's below the water surface. Okay, so if we calculate b squared minus 4ac using this equation, sorry, just now I forgot to fetch out, so here 1 minus 1 over 2, here will be 1 over 2. Okay, so if we sub the values inside, we will see that it is 4 over 9, meaning more than 0, which means it is this case. Right? So this will be our conclusion. And for part 2, we need to find the domain. Okay, so domain is x, and we need to find whether which are the parts which is below the water surface of the water. So if we look back to diagram 15b, we need to find the value of x that is below the water surface. So meaning we need to find the value here and here. Okay, so if we draw this into this diagram, now we need to find the value of here and here. Correct? And our y-axis, the x-axis is here, the y-axis is here. So these values all have a common thing, which is the y value is negative. Correct? Its y value is negative. So meaning we need to find the parts where it is y less than 0, or y we can replace it with the function which is g of x. So this is where we should start, gx less than 0. Okay, so the gx would be the equation that we got here, this one. Okay, so I'll just put it here. And now we just need to solve this quadratic inequality. So we just multiply 6 here, and then we will use calculator to factorize it out. Okay, so you'll get 2x minus 3 and 2x minus 1. Right, so if we convert this into answers, this would be 3 over 2, this would be 1 over 2. Okay, so this would be the roots. So since we are focusing on this part, so our answer would be the x is between 1 over 2 and 3 over 2. And with that, we have completed the discussion of this past year paper. So now I will flash out the answer schemes for these 15 questions to let you all see which are the parts that will be given marks. Okay? So I hope you all, after watching this video, I have helped you all to maybe revise some concepts in Addmath, and also maybe you have learned something new from this video, right? So if you have any questions regarding the discussion, you all can feel free to put your questions in the comment section below. Okay, so if you feel this video is also very beneficial to you, please give a like, subscribe, and share it to your friends and classmates as well. Alright, so thank you so much for watching this video. Stay safe, and I'll see you all in the next video. Bye bye.